Good morning, my dear student friends. Today we are going to discuss about double fertilization. Double fertilization. Very important part. Already you know what is the meaning of fertilization. Fertilization means fusion of male and female gamete. The fusion of male and female gamete is known as fertilization, and this fertilization was first discovered by the process of fertilization. Fertilization was discovered by scientist Strasbourg. Fertilization was first discovered by Strasbourg in 1884. And fertilization means fusion of male with female gamete. Fusion of male and female gamete. Fusion, mixing of male and female gamete. Male and female gamete. Female gamete. And it is a very important phenomenon during the sexual reproduction, because already we have discussed what is male and female gamete. Gamete are the unit of sexual reproduction. Just like spores are the unit of asexual reproduction. Not only spores, many structures are there, vegetative propagate, spores, different parts are there in case of asexual reproduction. But in sexual reproduction, gametes are important. So fusion of male and female gamete, this units is known as fertilization. Now we will move towards the steps of fertilization. It is very important how the fertilization takes place. The steps of fertilization. The fertilization in case of plants takes place in 4 steps. Number 1 is called germination of pollen grain. Germination of pollen grain. Germination of pollen grain and a growth of pollen tube. And a growth of pollen tube. Already you know what is pollen tube. In the development of male gametophyte we have discussed. Still here we will discuss in detail. Germination of pollen grain, growth of pollen tube. Second, entry of pollen tube. Entry of pollen tube inside ovule. Entry of pollen tube inside ovule. Inside ovule. Third, entry of pollen tube inside embryo sac. Entry of pollen tube inside embryo sac. Embryo sac. And last is the double fertilization. Double fertilization. So total 4 steps are there. Germination of pollen grain and growth of pollen tube, entry of pollen tube inside ovule, entry of pollen tube inside embryo sac, and double fertilization. First we will start with germination of pollen grain. So first, before going to germination of pollen grain, first you have to know about carpel. All of you know, carpel is the female reproductive part. Carpel is the female reproductive organ, female sex organ in case of plants, higher plants. And each carpel or pistil consists of 3 parts. Upper is known as a stigma. This part is known as a stigma. It is the receptive portion, stigma. And it is the landing platform for pollen grain. This part is known as a stigma. And long and slender, this portion is known as a style. And the lower portion, this portion is known as a ovary. So stigma, style, ovary. These are the 3 parts of carpel or pistil. If you look at the surface of stigma, this is the stigmatic surface. This stigmatic surface contains fluids. Generally, it contains the surface of stigma contains some fluids, and these fluids contain sugar, gum, and resins. There is a fluid, accumulation of fluid. The stigmatic surface contains a fluid, and this fluid or this liquid contains what? It contains sugar, gum and resins. These are the chemicals mainly. These chemicals mainly present on the surface of stigma and which make the surface of the stigma sticky in nature, sticky, such that anything can attach to the surface of the stigma. So sticky means which can help in attachment. And attachment of what? Attachment of pollen grain. Because pollen grain has to land on the stigmatic surface. Already we have discussed in development of male gametophyte. So the stigmatic surface contain a fluid, and this fluid contains sugar, gum and resins. But important thing, if you look at the stigmatic surface contains many swellings. I can show it in another large view. This is the stigmatic surface. This stigmatic surface contains small swellings like this. Now I am showing here. You can see the stigmatic surface. In a microscope, if you look, you find the large swellings at the surface, and these are called as a stigmatic papilla. These are known as stigmatic papilla. Stigmatic papillae. And inside the stigmatic papillae, few important things are present. If you look inside the stigmatic papillae, it contains some hydrophilic protein and hydrolytic enzymes. Two important things you will find: hydrophilic protein and hydrolytic enzymes. Hydrophilic protein inside the stigmatic papillae. What you find? Hydrophilic protein. Number one is hydrophilic protein. Second is a hydrolytic enzyme. Hydrolytic enzymes. Hydrophilic protein and hydrolytic enzymes. So two important things are present. Here hydrophilic. Hydro means water, philic means loving. Hydro means water, philic means loving. So water loving proteins are there. What is the main function of a hydrophilic protein? They can bound to water. They can hold the water molecules. So that's why inside the stigmatic papillae, inside these swellings, the water content is high. The amount of water is high. So that's why the surface is always moist. Here the fluid, what I have written, the fluid contains sugar, gum and resins. In addition to that, water is also present because it is a fluid. So hydrophilic protein keep or bound to the water molecule easily. And what is the hydrolytic? Hydrolytic means breaking enzyme. The enzymes which can break. Its function we will discuss later. What is the function, how it is involved in this process. So you remember here, two things are present: hydrophilic protein and hydrolytic enzyme. Hydrophilic protein, so always bound to water molecule. And what happens actually when at the time of pollination, when pollen grain, already in pollination part we have discussed, the pollen grain are transferred by air, water or any medium, insect, and the pollen grain finally reach at the stigmatic surface. This is called pollination. Pollination means transfer of pollen grain from anther to stigma. So now already pollen grain reached. This is the pollen grain. When the pollen grain reach at the stigmatic surface, what happens? The stigmatic papilla burst or collapse. There is bursting of this stigmatic papilla. The stigmatic papilla bursts, or there is a collapsing of this stigmatic papilla. And when the stigmatic papilla collapse, the hydrophilic protein and hydrolytic enzyme come out to the surface and they cover the entire surface. So that's why the entire surface of the stigma become wet, containing this fluid, and it becomes sticky. So that's why stigmatic surface becomes sticky in nature. The stigmatic surface becomes sticky. So this part must be clear. How the stigmatic surface becomes sticky? The stigmatic surface contains a fluid containing sugar, gum and resin, and the stigmatic papillae which contain hydrophilic protein and hydrolytic enzyme. After pollination, when pollen grain reach, the stigmatic papillae burst and the surface become wet. So that's why the surface always moist. And when one pollen grain comes with the help of any pollinating agent. Once the pollen grain reach, it can easily bound to the surface. The main function of these chemicals, what we have written here, so all the chemicals together helps in sticky nature, such that pollen grain can easily stick to the surface of the stigma. So this is all about your stigmatic papillae. How stigmatic papillae helps in attachment of pollen grain. But important thing, how the double fertilization takes place. How fertilization takes place. So here, after reaching at the stigma, the pollen grain shows germination. There is germination of pollen grain. So that's why here I have written germination of pollen grain. What is germination? Germination means from the pollen grain some structures will come out. There is a formation of some structure from the pollen grain, and for that you have to know about the structure of pollen grain. Already in the pollen grain part we have discussed each pollen grain consists of two cells. Each pollen grain, when they reach at the stigmatic surface, not at the end it contains three cells, I will tell. But now when pollen grain reach at the stigmatic surface in 60% plant, it contains two cells. One very large cell known as a vegetative, and a small cell known as a generative cell. Two cells are there, so that's what is called two cell states. The pollen grain exists in two cell states, and pollen grain covered by two covering. One is exine, another is intine. So actually what happens during this germination of pollen grain and the growth of the pollen tube? First step we have to discuss. This is the carpel, stigma, style, and the lower part is ovary. Okay, now one pollen grain reached at the surface of the stigma. Already I have discussed the stigmatic surface is always wet or sticky due to presence of these chemicals, fluid containing gum, resin, sugar, and due to bursting of stigmatic papillae or collapsing of stigmatic papillae. Now one pollen grain reached. Already you know the pollen grain is covered by two covering. One is exine, another is intine. And exine possesses small pores known as a germ pore. These are the germ pore. The exine layer possesses germ pores. You can see easily. These are the germ pores. And this is exine. Outer covering of pollen grain is exine. Inner covering of pollen grain is intine. And inside this intine, two cells. Large cell is known as a vegetative. Small cell is known as generative. What happens actually when one pollen grain reach at the stigma after pollination? It absorbs moisture and sugar. Already we have discussed the stigmatic surface contain what? Sugar. It contains sugar. It contains moisture. Moisture means water, and many chemicals, resin, gum, different things. And these two are very important. Sugar and moisture are maximum. So after reaching at the surface of the stigma, the sugar and moisture is absorbed by the pollen grain. The pollen grain absorbs sugar and moisture. And after absorption of sugar and moisture, what happens? The volume of the cytoplasm increased. Volume. Now we can compare. Initially, what is the volume of the cell? This is the pollen grain, and now the volume is increased. So definitely, the volume will increase just like a expanding balloon. When you enter more and more air inside a expanding balloon, the balloon will expand or increase in volume. Similarly, here also, when there is sugar and moisture absorption by the pollen grain, after reaching on the surface of the stigma, the sugar and moisture is absorbed by the pollen grain, and after absorption of these two chemicals, there is increase in cytoplasm, volume of the cytoplasm. The cytoplasm of what? Two cells are present, vegetative and generative cell. So vegetative, generative cells cytoplasm will increase. So that's why these two cells, vegetative cell and generative cell, will put pressure. When there is expansion of volume, it will put pressure in all the direction over the wall of the pollen grain. And wall of the pollen grain is made of two layers, exine and intine. Already I have told you, exine is most resistant. It is made of sporopollenin, one special chemical. And intine is made of pectocellulose. So intine is thin. Intine is elastic in nature. Intine can be expandable. It can relax or expand, contract. But the exine layer cannot show this type of phenomenon. So that's why what happens when the cytoplasm of vegetative and generative cell will increase due to entry of more sugar and moisture, the pressure will develop on the wall. The pressure will develop on the wall. And which cell will develop more pressure? Vegetative cell, because vegetative cell are larger. The larger vegetative cell will put pressure on the intine layer, and due to that pressure, the intine layer will come out due to the pressure. What happens? The intine layer, the inner layer, inner layer, second layer. The inner layer, what happens? The inner intine layer will come out due to pressure of vegetative and generative cell, and this structure which come out of the pollen grain in the form of a tube-like structure is called as a pollen tube. This structure is called as a pollen tube. So tube-like structure is formed. One tube-like structure is formed. So what is pollen tube? Pollen tube is a tube-like structure which comes out due to expansion of or due to evagination, expansion of intine layer. When intine layer come out through one of the jaw pore, it is called as pollen tube. And this pollen tube are formed because of pressure of two cells, vegetative and generative cell. And which cell is a larger? Vegetative cell. So that's why as vegetative cell is larger due to pressure, the vegetative cell also come out. This cell also come out because of pressure. When something puts pressure, that structure also has to come out. Clear? It does not mean the cell will remain inside and only pollen tube will come out. When pollen tube come out, along with the tube, this cell has to come. So that's why vegetative cell followed by generative cell. First vegetative cell comes, at the back of vegetative cell, the generative cell comes. And now this pollen tube, now the pollen tube grows inside the style. This part is the style. So first it is formed on the stigma. Now it grows towards the style. How? If you look clearly at the diagram, this is the stigmatic surface, this is the style, and lower portion is ovary. This is the last portion, ovary. After formation of pollen tube, now pollen tube is already formed from the intine layer. Intine layer comes out in the form of a tube-like structure. Now the pollen tube is growing. The pollen tube, the tube-like structure, now move towards the ovary. Stigma, style, now it is growing downward because fertilization takes place at the lower place. So now the pollen tube is growing towards ovary, and when the pollen tube grows, what happens? The pollen tube content, at the tip of the pollen tube there is a vegetative cell, large, followed by generative cell. And at this time, what happens? The tip of the pollen tube grows. Tip. This is the tip of the pollen tube. Tip. Tip means terminal part. Tip of pollen tube. This tip of the pollen tube having important function. This tip of the pollen tube releases some enzymes. Some important enzymes are secreted. And what are the enzymes? One is cutinase. Another is pectinase and other hydrolytic enzymes. Hydrolytic means breaking. Hydrolytic enzymes. Other hydrolytic enzymes. Cutinase, pectinase and hydrolytic enzyme. What is the function of cutinase? It can break the cutin. Cutin is a chemical present in the cell wall of the plant cells. So cutinase, it can break the cutin chemical. Similarly, pectinase, it can break the pectin chemical. And hydrolytic enzymes, it can break the other chemicals. So that's why due to these enzymes which are secreted by tip of the pollen tube. Tip means this part. This part of the pollen tube releases these chemicals or enzymes. Due to release of this chemical, the tissue undergo breakdown, or the cells which are present in the style, these cells of the style undergo breakdown, and there is creation of a passage. One path is created such that the pollen tube can easily move through that path. Just like you can compare when some VIP person comes, just like PM or any celebrity come to any public place, what happens? The security guards separate and create a passage by separating the people. Yes or no? So similarly, what happens? The function of these enzymes, tip of the pollen tube, because this tip has to grow. This tip of the pollen tube means this vegetative cell secretion. This cell secrete these chemicals, cutinase, pectinase and hydrolytic enzyme. Due to these enzymes, what happens? These cells undergo breakdown. These cells break and there is formation of a path, and this clear path helps in easy entry or growth of the pollen tube towards the style. But what happens during this growth of the pollen tube? One important change takes place. When the pollen tube grows towards the ovary. Now we have discussed the pollen tube germination takes place. Germination means tube will come out, and now tube is growing. Tube is growing towards ovary, towards the lower part, towards ovary. The pollen tube is now growing towards ovary. Lower part is ovary. This portion is ovary. It is moving towards ovary. During the growth of the pollen tube, one change takes place. Already I have told you, the tip of the pollen tube is occupied by vegetative cell, followed by what? Genitive cell. The tip is vegetative cell, and at the back of it is genitive cell. This genitive cell undergo one mitosis here, inside the style. When it grows inside the style, the genitive cell undergo mitosis. There is a mitosis of genitive cell. Mitosis, what? Mitosis of genitive cell. Mitosis of generative cell. Mitosis of generative cell takes place. And already you know mitosis yields two cells. Mitosis, when mitosis takes place, there is a formation of two cells. So previously there is vegetative cell. At the back of vegetative cell, genitive cell is moving. So now genitive cell divides into two cells again, because there is a mitosis of genitive cell. Now you not find any genitive cell at the back of vegetative cell. Now you find two cells, and these two cells are called as two male gametes. Two male gamete. You have to remember, male gamete is formed in which part of the style? This style part. Which part of carpet? This is the style. Upper is stigma. This part is style. This part is ovary. So during the growth of the pollen tube inside the style, when the pollen tube grows inside the style, the tip is occupied by vegetative cell, and the tip secretes the enzymes for easy entry to create passage, and genitive cell divides by mitosis. The genitive cell divides by mitosis to produce two male gametes. So that's why the pollen tube is a structure which carries three cells. One vegetative cell at the tip, at the back two male gametes. Previously two male gametes are called genitive cell because they are produced from the genitive cell. And the two male gametes which are produced, these are non-motile. Non-motile means not capable of self-movement. They cannot move because they lack flagella. There is no flagella. Unlike the animal sperm, in case of animal, you find a sperm contain flagella, tail. Sperm can move, or male gamete can move by itself. But here, the two male gametes are non-motile. So that's why the tube helps to carry the pollen tube. The tube helps to carry the vegetative and two male gametes towards the ovary, because inside the ovary there is finally fertilization. And when the pollen tube grows, this is the growth of the pollen tube. Pollen tube is growing downward from the stigma towards ovary. So how this growth takes place? For this growth, one important reason is there. One reason is there behind this growth. What happens? Already we have discussed inside the ovary some egg-like structures are present. These egg-like structures are called as a megasporangium or ovule. As I know, ovule. This ovule secrete certain chemicals. These ovules secrete certain chemicals, and these chemicals attract the tube. The tip of the tube is attracted towards chemical, because between all the cells there is some attraction. Just like sperm get attracted towards the ovum during fertilization time, you have read in case of human reproduction. Similarly, here these cells or the tip of the pollen tube get attracted towards chemical present inside the ovule or inside the ovary, you can say, because ovule is a part of ovary. So that's why the growth of the pollen tube, when the pollen tube grows, this growth is called as a chemotropic movement towards chemical, chemotropic, and it is apical. The growth of the pollen tube is apical and chemotropic. Chemotropic growth, another is apical growth. These two things you have to remember, important things. Why it is called chemotropic growth? Because some chemicals are secreted inside the ovary by ovule which attract the pollen tube. And why it is apical? Apical means only tip is growing, this part is growing, this part are not growing, only tip. After some time this part will extend, after some time this part will extend, so tip is growing. So that's why it is called chemotropic or apical growth. And this completes your first step. We have completed about first step. We have not started the second step. Second step is written entry of pollen tube inside ovule. Inside ovule we have not discussed, only germination of pollen grain and the growth of the pollen tube. You have to remember, first pollen grain reaches at the stigma, it absorbs sugar and moisture. Already you have discussed why the surface is always sticky. It contains fluid containing sugar, resin, gum, so that's why sugar and moisture is absorbed. Stigmatic papillae burst to release water, and when the water and the sugar enters, the volume increases. Due to that increase in volume, pressure is put over the intine layer, and intine come out in the form of a tube-like structure that is called pollen tube, and this pollen tube now grows. And when the pollen tube grows, the tip of the pollen tube, last part of the pollen tube, end of the pollen tube is occupied by vegetative, at the back genitive, and the genitive cell undergo mitosis to produce two non-motile male gametes. So now three cells. So in the first step, germination of pollen grain and the growth of the pollen tube. The pollen tube is now growing and already germinated. Germinated means something come out. Something means pollen tube. Pollen tube already come out of the pollen grain. So now we will move towards the second step, entry of pollen grain, entry of pollen tube inside the ovule, entry of pollen tube inside the ovule. How it enters inside the ovule and perform different function. The first step is very important. You have to remember, in the first step, germination of pollen grain and growth of the pollen tube. When pollen tube grows, it contains three cells, one vegetative and two male gamete. Genitive cell already divided. So what happens? Already we have discussed, inside the ovary there is some egg-like structures. These egg-like structures are called as ovule. Already you know, these egg-like structures are known as ovule. And second step is written, entry of pollen tube inside ovule. How the pollen tube enter inside ovule. Already you have discussed, after formation of pollen tube, the pollen tube grows. Now the pollen tube grows inside the style, and finally it reaches in the ovary because of chemicals. So that's what is called chemotropic movement. After reaching ovary, when once the pollen tube reaches the ovary, it always directed towards the ovule. If one ovule is present, it directed towards that. If many are there, it will directed towards one ovule which is mature enough and secrete more chemical. Let three ovules are there. If this ovule is secreting more chemical, it will get attracted towards that ovule, not towards this ovule or not towards this ovule, because these two are immature. So it will move towards mature ovule if more than one is present. Okay. So now what happens? The pollen tube will enter inside the ovule. Now it will enter inside the ovule. Maybe this ovule if mature, if this ovule mature, then it will enter into this ovule also. So now we can see the structure of ovule. Already we have discussed ovule. In the female gametophyte part, the ovule consists of important parts. The stalk of ovule is called funicle. This part is called as funicle. This upper part is called as a micropyle, and the lower part is called as a chalaza. This is micropyle and micropyle. This is chalaza. And already we have discussed, inside the ovule there is some mass, nucellus, and this covering is called integument. Integument is the covering. Integument is the covering, and inside this there is a mass of cell called as a nucellus. And almost at the center there is a sac-like structure known as embryo sac. This structure is known as embryo sac. Embryo sac. This structure is known as embryo sac. So what happens? Now the pollen tube has to enter inside this ovule, because the second step is written, entry of pollen tube inside the ovule. So now it will enter inside the ovule. But when the pollen tube enter inside the ovule, there is three ways, three paths. The pollen tube can enter through the micropyle. This micropyle is the opening. One pollen tube will come with one vegetative and two male gametes. It can enter through the micropyle, or it can move in opposite direction like this. It can move in opposite direction. Actually, now one question comes: the pollen tube, how it moves in micropyle and how it bends? Actually, it not bends. It depends on the position of the ovule. It depends on the position of the ovule. Let one ovule is present like this. Let ovule is present like this. If ovule is present like this, the micropyle become this part. This part is the micropyle. If it is a straight ovule, the pollen tube directly enter. If one ovule is present like this, let inverted. One ovule is present in inverted manner. Micropyle is present at the lower part, and this is attached like this. Then pollen tube directly enter through the chalaza, or in any part through the integument part. So that's why there is three ways. The pollen tube can enter into the ovule in three ways. It can enter through micropyle, it can enter through chalaza, or it can enter through the middle part. Middle part means in between the micropyle and chalaza, in this part, middle part, like this. It can enter through the integument. So there is three ways. In the entry of pollen tube inside the ovule, there is three options, three ways. The pollen tube can enter through the micropyle, and this process is called porogamy. And these are the important question directly comes in entrance as well as in your board. When pollen tube enters through micropyle, direct question comes. When pollen tube enters through the micropyle of the ovule, it enters inside the ovule through the micropyle, that is called porogamy. When it enters through the chalaza, inside the ovule through the chalaza, it is called chalazogamy. And when it enters through the middle part, it is called as a mesogamy. But out of these three important method of entry, the porogamy takes place in 70 to 80% plants maximum. The maximum important type is porogamy. The pollen tube enters inside the ovule through the micropyle. Micropyle is the important part. So that's how you completed the second step. First and second step completed. Germination of pollen grain and growth of the pollen tube. Second, entry of pollen tube inside the ovule. Third is entry of pollen tube inside embryo sac. What is embryo sac? Already you have discussed embryo sac. This structure is called embryo sac. Now after entry inside ovule, the pollen tube reached inside the ovule. Now it has to enter inside the embryo sac. It is observed when the embryo sac, turn of embryo sac comes, the pollen tube has to enter through only one path. Important things you have to remember. The entry of pollen tube inside the ovule takes place in three ways. Already you have discussed. There are three ways. Maybe porogamy. If porogamy not possible, chalazogamy. If chalazogamy is not possible, again another option is there, mesogamy. Through any way it can enter. But when the pollen tube, entry of pollen tube inside embryo sac comes, there is only one. Irrespective of any paths it followed during the entry of ovule, it has to follow only one path in the entry of embryo sac. When it enters into the embryo sac, there is only one path. How? Now we have to draw an embryo sac. And embryo sac structure already in detail we have discussed. Embryo sac. Now I am removing this embryo sac to outside. Remove this embryo sac to outside. This is the embryo sac. And already we have discussed embryo sac having two ends. This is micropylar end, because this part is micropyle. So this end is micropyle, this end is facing towards chalaza. This is chalaza end. And there is 7 cell and 8 nucleated structure. This embryo sac or female gametophyte is 8 nucleated but 7 cell. And out of 7 cell, 3 cells are present at this end. Already we have discussed. Yes or no? 3 cells. What are the 3 cells? One is called egg cell and 2 synergids. These are the 2 synergids. And the synergid contain a filiform apparatus. All of you know. This is the filiform apparatus. And filiform apparatus is the only characteristics of synergid. These are the 2 synergids. And this middle cell is known as egg cell. 3 cells completed. And at the lower end, 3 antipodal cells are there. And at the center, there is a large central cell. With 2 polar nuclei. So that's the number of nuclei is 8. 1, 2, 3, 6. Middle. At the central cell, 2. So total 8 nuclei. But 7 cells. 3 cells, it is a binucleated cell, central cell. This is the embryo sac. What happens actually? Once the pollen tube reached the ovule, this is the ovule. Once the pollen tube reach inside the ovule through any of these paths, any of 3 out of this 3 pathway, now it has to enter inside the embryo sac. And how it will enter inside the embryo sac? Actually, this filiform apparatus which is present, this part, filiform apparatus is the part of synergid cells. It secretes some chemical hormone. Chemicals are secreted, and this chemical attract the pollen tube. So that's why pollen tube attracted towards that. So that's why only pollen tube enter inside the embryo sac through that path where the synergy is present, because chemical is secreted by synergy. So that's why from the beginning I have told you the pollinative growth is chemotropic, and that chemical is secreted by synergy. Synergy is a part of embryo sac, and embryo sac is a part of ovule, and this ovule is present inside ovary. So that's why from the beginning I am repeatedly telling it is chemotropic movement. The pollinative movement is chemotropic. Why it is chemotropic? Because this stigma style ovary, and inside the ovary this ovule is present, and inside the ovule embryo sac is present. Embryo sac contains synergid, synergid contains secret chemicals, and towards that chemical the pollinative grows. So that's why it is towards chemical or chemotropic movement. Chemotropic movement. So important thing here you have to remember, this chemical is secreted mainly by filiform apparatus. So that's why filiform apparatus guide the entry of pollen tube. Sometimes direct question comes: who guide the pollen tube? Who guide the pollen tube? Pollen tube is guided by the filiform apparatus. The chemical secreted by the filiform apparatus. Main function of filiform apparatus is to guide the entry of pollen tube. So that's why now pollen tube get attracted, and two ends we have written. The upper end is called micropyle end, lower end is called charazal end. So that's why from here it is confirmed the pollen tube will enter inside the embryo sac only from the micropylar end. So that's why here I have written there is 3 options for entry inside the ovule, but there is only 1 option for entry inside the embryo sac. So that's why here you have to remember the pollen tube will enter. The tube will enter inside the embryo sac only at the micropylar end, irrespective of its entry inside the ovule. Irrespective, it can enter in any respective, anywhere inside the ovule, but inside the embryo sac it will enter only through the micropylar end because of this chemical secreted by filiform apparatus. So now, how it enters the pollen tube? How pollen tube enters inside this embryo sac? There is again some options how the pollen tube. It will enter inside the embryo sac in this end only, but it can enter. How it can enter? The pollen tube can enter by degrading one synergid. It can destroy one synergid. Already I had told you, when pollen tube is growing downward, the tip of the pollen tube secretes certain chemical, cutinase, pectinase, and hydrolytic enzyme. Due to that chemical, what happens? The one cell, one of the synergid bursts, one of the synergid get destroyed, and the pollen tube enters through that synergid like this. This is the pollen tube. Now the pollen tube entered into one of the synergid. You can see one synergid is alive. One synergid, it is intact synergid. There is no harm to this synergid, but this synergid destroyed. So that's why it shows that due to secretion of chemicals from filiform apparatus, what happens? The pollen tube enters at the micropylar end through one of the synergid. It destroys one of the synergid and enters. Or if it is not possible, it can enter between the gap between two cells. Gap between synergid and egg cell. Here gap is present. These are very microscopic. We are looking it under microscope. So that's why here space is not visible. What space is available here? And the pollen tubes are not that much thickness diameter. They are very thin. So that's why they can easily enter. So that's why the pollen tube enters into this embryo sac through one of the synergid by destroying one of the synergid, or between the gap of synergid and the egg cell. So anyhow, now the pollen tube reached, and already we have discussed the tip of the pollen tube contain the vegetative cell. Tip of the pollen tube contain vegetative cell. At the back of it, what is present? Genitive cell, not genitive cell. 2 male gametes are present. So 3 things are present from the beginning. From this stage we have discussed. The first stage, from the beginning there is 3 cells. Vegetative cell, at the back 2 male gametes, and we have reached at the third step. So what happens? Now the pollen tube reached inside the synergid, and after reaching synergid, what happens? It absorbs lot of water. The tip of the pollen tube absorbs lot of water, and it is swell and bursts. There is a bursting of the tip of the pollen tube. The tip of the pollen tube bursts and releases the entire content. All the content, almost all the content, means vegetative cell and 2 male gametes are released here in the cytoplasm of synergid. Where the cytoplasm of synergid present. Previously, this place was occupied by synergid. Now there is a cytoplasm of synergid because the cell is already destroyed. So that's why cytoplasm means water part of that cell is present. So that's why now at this place the tip of the pollen tube burst, the cap of the tube burst, and these 3 cells are released. Vegetative cell is the larger cell followed by 2 male gametes. Generative cell is already divided. So what happens after release of these 3 cells? The vegetative cell immediately degenerates. There is a destruction of vegetative cell. The vegetative cell degenerates. After degeneration of vegetative cell, only 2 male gametes are available. Now I am showing here the 2 male gametes are available inside embryo sac. This is the egg cell. This is another synergid. One synergid is already destroyed, and this is the large central cell with binucleated structure, 2 nuclei, and these are the 3 cells, antipodals. Okay, so what happens here? There is only 2 male gametes are available because vegetative cell is also destroyed. The vegetative cell also destroyed. So now what happens? It is part of double fertilization. Now double fertilization comes. How double fertilization takes place? Because already entry of pollen tube inside embryo sac we have completed. Now come to double fertilization. In double fertilization takes place twice. Fertilization. What is fertilization? Fertilization means fusion of male gamete with female gamete. Fusion of male gamete with female gamete is known as fertilization. But here fertilization takes place 2 times. So that's what it's called double fertilization. Double fertilization. And what is double fertilization? In detail we have to discuss. Here 2 male gametes are available. This is one male gamete, this is another male gamete because genetic cell divided. So sometimes question comes, male gametes are produced from which cell? Genetic cell produces male gamete. Genetic cell produces male gamete. Or what is the mother cell of male gamete? Which is the mother cell of male gamete? Genetic cell is the mother cell of male gamete. Genetic cell is the mother cell of male gamete. So now 2 male gametes are produced. After formation of 2 male gametes, one male gamete directly get fused with the egg cell. One male gamete fused with the egg cell. So what happens? There is a fusion of male gamete with egg cell. Male gamete plus egg cell, and egg cell is called female gamete. Egg cell is also called as female gamete. Other name of egg cell is female gamete. So now the female gamete and male gamete both are haploid. This male gamete is haploid, egg cell is also haploid. If you have not known how they are haploid, go to the previous lecture and watch clearly. These are the haploid. So male gamete is haploid and female gamete is haploid. Now there is a fusion of male gamete with egg or female gamete. Due to fusion, there is a diploid structure formation known as a zygote. There is a formation of a zygote, and a zygote is diploid. A male gamete and female gamete or egg produces zygote, and this process of fusion takes place here at the micropylar end. The fusion, because they are located at the micropylar end. So now male gamete get fused with egg cell to produce a zygote, and this process is known as a syngamy. You have to remember, first fusion is known as a syngamy, or it is called as a generative fertilization. This is the other name. Generative fertilization, syngamy or a generative fertilization. So now the first fertilization completed, but here we have written double fertilization. Fertilization has to take place twice. So in the first fertilization, there is a syngamy, fusion of male gamete with egg. But what happens? Out of 2 male gametes, you can see here, 2 male gametes are present. Out of 2 male gametes, 1 male gamete already fused with the egg and formed one zygote. So that's why zygote is formed. 1 male gamete fused with this egg and a zygote is formed. But another male gamete, now it moves towards the nucleus of the central cell. The central cell, it is moving towards the central cell. And already you have discussed central cell contain 2 polar nuclei. And when this male gamete, the rest male gamete, 1 male gamete already used, the another male gamete which is present, now it migrates towards this polar nuclei. and when it migrates towards polar nuclei, the two polar nuclei fuse with each other first, and the two polar nuclei fuse to form a structure. Already in the previous classes I had told it is called a secondary nucleus. Secondary nucleus in female gametophyte part we have discussed. You can watch that lecture again. So here two polar nuclei fuse to form a secondary nucleus, and when the two polar nuclei fuse, it forms a 2n structure. 2n. So because two polar nuclei are fused, secondary nucleus, or it is also called definitive nucleus. Definitive nucleus. So definitive nucleus is formed just before the fertilization. So just before the fertilization, when the male gamete move towards these two nuclei fuse and form a secondary nucleus. Now what happens? That secondary nucleus is how much? 2n. Why it is 2n? Because it contains two nuclei. It contains two nuclei. Now with this secondary nucleus, another male gamete get fused. So another male gamete get fused. So that's why two male gamete are used. Already you have discussed one male gamete is used here with egg, another male gamete is used with the secondary nucleus. So that's why it produces another fertilization product. It produces another product, and but this product is different because secondary nucleus is 2n and male gamete is n. When 2n and n get mixed, it produces 3n, a triplet structure, and this structure which is produced, it is called primary endosperm nucleus. Primary endosperm nucleus. Primary endosperm nucleus, or shortly written as a PEN. PEN, primary endosperm nucleus. So how PEN is formed? First we have discussed zygote, how zygote is formed. Now this is the PEN, primary endosperm nucleus. Zygote is formed by fusion of male gamete with egg, but PEN, it is a 3n structure. It is produced by secondary nucleus. And how secondary nucleus is formed? By fusion of two polar nuclei. These two polar nuclei get fused to form secondary nucleus, and another rest of the male gamete fuse with this secondary nucleus to form this PEN. So that's why in this process 3 nuclei are involved. In the second fertilization, the 3 nuclei are involved. Two polar nuclei are first fused, and another male gamete at the end. So total 3. So that's why this process is called triple fusion. Sometimes direct question comes, why it is called triple fusion? 3 nuclei get fused. What is syngamy and what is triple fusion? Syngamy is the fusion of male gamete with egg to produce zygote, but triple fusion is the fusion of secondary nuclei with male gamete to produce primary endosperm nucleus. So that's why here two fertilization takes place. First syngamy takes place, second triple fusion, because two male gametes are coming from the beginning. So that's why inside the embryo sac you find two types of fertilization. One is syngamy, another is triple fusion occurring together. As syngamy and triple fusion occur together, this is called as a double fertilization, because fertilization takes place twice. So double fertilization, because of this it is called double fertilization. Sometimes double fertilization comes as a long question, or sometimes direct. This double fertilization will come as 2 mark short note. So you have to mention, if 2 mark question comes, you have to at least mention these 2 steps. Syngamy and triple fusion takes place inside the embryo sac, so that's why it is called as a double fertilization. And this double fertilization was discovered by scientist Nawasin. This is also very important. Nawasin. Fertilization was discovered by Strasburger. If question comes only fertilization, answer is Strasburger. Strasburger discovered fertilization only, but Nawasin discovered double fertilization. Double fertilization was discovered in plants by Nawasin in Lilium and Fritillaria, 2 plants, Lilium and Fritillaria. So this completes your double fertilization. Thank you.